All right, so we are on 8A right now. And so we are on problem number one. We're starting with problem number one. And number one says, found the value of the expression when z is equal to negative 15. So they said z is equal to negative 15. All right, so basically all we're going to do is replace the expression. So we have the expression. We have 4z minus 3. That's in our numerator. And then we have z minus 6 in our denominator. So now all we're going to do is rewrite the problem, taking out the z and plug it in negative 15. So we always rewrite the problem applying the numerical value for the variable. So now when I rewrite this, it's going to be 4 times negative 15 minus 3 over negative 15 minus 6. So all I did was take out the variable and I replaced the variable with the known value, which was negative 15. Now we will follow the order of operation. Okay, we will now follow the order of operation to now solve this. So we're going to simplify the numerator first and then simplify the denominator. So in my numerator, I have 4 times negative 15. That would give me a negative 60. So I have negative 60 now minus 3 over negative 15 minus 6. So all I did was multiply 4 times 15. Remember, anytime, negative 15. Remember, anytime we have a number on the outside of the parentheses, we multiply times the number on the inside.
Professor,
Yes.
excuse me.
Yes.
I don't know if you usually check your emails, but I sent you an email. I already did this assignment, and I was wondering if I could take my test on Wednesday.
For this lesson?
Exam 3?
Oh, exam 3. There's no school Wednesday.
Oh, yes, I forgot.
Yeah, there's no school Wednesday. So if you want to take exam 3, you got to take it now. And you got to turn on your camera.
Yeah. I'm not in a position to take it now.
Okay.
And I can explain why. I just don't want to do it in front of everybody.
All right, no problem. No problem. I did check my email. I didn't see an email from you. Yeah, the only person I got an email from was Miss Cleland.
Yeah, I sent you life. Was it life lessons? Is that your email?
Oh, no.
What's your email address?
It'll be snewton@fscj.edu.
Okay, I'll send you an email explaining why.
Okay, no problem.
Right.
All right. All right, so now here we go. So now we have this. So now we can go ahead and simplify this. Now we know we follow the sign rules. We have the double negative, so we add the numbers up. So we have negative 60 minus 3, which give me negative 63. And then negative 15 minus 6 would give me a negative 21. So remember, anytime we have the double negative, we follow that sign rule. And we add the numbers, and your answer always come out to be negative. Now we can go ahead and divide and simplify this to break this down. 63 divided by 21 is 3, And we know that a negative divided by a negative is a positive. So our answer would be 3 as a whole number.
If my numbers don't divide and don't simplify, I would just put in the fraction.
Yeah, you would keep it as a fraction. So if your numbers don't divide, you would keep it as a fraction.
Can you do it one more time?
All right, one more time. I'm going to use the same problem, okay? Now remember, you got to apply the sign rules. And I think I gave you all a sheet to use. So remember, all we're doing is replacing z with negative 15. So everywhere we see z at, we plug in negative 15. So I'm going to rewrite the problem. 4 times negative 15 minus 3 divided by negative 15 minus 6. So you see, this is where z was at. They said the value of z was negative 15. So I took out z and I plugged in negative 15.
Yeah.
Now I'm going to go ahead and do the order of operation. I'm going to multiply 4 times negative 15, which gives me negative 60 minus 3. And that would give me negative 15 minus 6. Now you got to remember this sign rule. You got the double negative here, double negative here. So we're adding the numbers, but your answer going to always be negative. So we add the numbers. 60 plus 3 will give me 63, but that will come out to be negative 63. 15 plus 6 will give me 21, but that will be negative 21. And now all we're going to do now is divide. 63 divided by 21 is 3. And a negative divided by negative is a positive. So I've come out to a positive answer. Now, if you have a problem like this, and if the denominator doesn't go into the numerator evenly, we keep it as a fraction.
Thank you. I saw when that happened. I copied one of your numbers.
Okay, yeah, make sure you use your own numbers on your problems.
Yeah, thank you.
You're welcome. All right, let's go ahead and go to problem number 2. So problem number 2, we're doing the same setup here. So we have x plus 16 divided by x plus 1. And they said x is equal to 1. So all I'm going to do now is take out x and replace it with a 1. 1 plus 16 and 1 plus 1. So what we're doing here is taking out the variable and replacing the variable with the value that they've given us. Now we can do the math. 1 plus 16 will give me 17. 1 plus 1 gives me 2. And so therefore, 2 doesn't go into 17 evenly. So we keep it as a fraction. And you're going to be seeing a lot of fractions in this lesson. And that one was relatively easy. What happened to... Okay. Yeah, this been happening to me all day. I be in an app and it just keep closing out. All right, so we're going to move to problem number 3. All right, so we're applying the same thing with problem number 3. They've given us values for the variable, and all we're going to do is replace the values. So we're at problem number 3 now, and they're telling us that y is equal to -2. And so in my equation, I have y to the 3rd power divided by y to the 2nd minus 1. Now, all I'm going to do is take out the y and replace it with -2. So I have -2. Now, watch this. I got to put that in parentheses. To the 3rd power. And then I have -2 to the 2nd power minus 1. Now, the reason why I put that in parentheses, because of that exponent there. Because remember, when we multiply these, that's -2 times -2 times -2. We got to apply the sign rule. So we know that a negative times a positive will give me a positive. A negative times a negative will give me a positive. Now that we have a positive times a negative will give me a negative. So anytime your exponent is an odd number and you have a negative on the inside of the parentheses, your answer will come out to be negative. All right? So your answer will come out to be negative. So in this case, when I simplify this, that's -2 to the 3rd, which is -2 times -2 times -2, which would give me -8. And now I have -2 to the 2nd power, which is -2 times -2, which gives me a +4 minus 1. And now my last step is to completely simplify my denominator. 4 minus 1 will give me 3. So my solution will be -8 over 3, or -8/3. So that's how we do problem number 3. Just basically take out the variable and apply your sign rules. All right, let's move on to problem number 4. Problem number 4. All right, so now we're going to start rationalizing expressions. All right, and here's where factoring is going to come into play, and here's where we're going to apply certain rules to the situation here so that we can get to our solutions. You're going to realize that we're going to have variables, we're going to be factoring, and we're going to end up having whole numbers as our answer. It's crazy. But anyway, we're on problem number 4. And so I have x plus 8 over 8 plus x. Well, for this problem here, we can get ahead and do 2 things. We can do the commutative property of addition. We can apply the commutative property of addition by basically flipping the x plus 8 so we can get common factors here. So we have 8 plus 8, x plus 8. And then we can switch this around using that property. Because it doesn't matter what value we use for x, we will still get the same answer. So that's why we can use that property. Now we have x plus 8 over x plus 8. Anytime we have the same variable and number in the numerator and the denominator, that is simplified to 1. Now you don't have to do this step when it's addition. You don't have to do that step with addition. If you have the same variable and same constant and it's separated by an addition, the operation of addition, you can just go ahead and simplify it to 1. Because we know any number or variable over itself is always equal to 1. And that's problem number 4.
Professor, can you explain that one again? I'm sorry, I was doing the previous problem.
Oh, basically, these are the same variables and same constants. See that? You don't have to do this step. You can use a commutative property of addition. No, I think it's the associative property of addition. To flip this around so that you can have the same variable and constant. But if you see that they're the same, you can just basically simplify it. So anything over itself is 1. It's the same thing as this, 9 over 9. 9 over 9 is equal to 1. It'll be the same thing as if I had x over x. X over x is equal to 1.
Gotcha. Thank you.
Okay, you're welcome. All right, that's problem number 4. All right, problem number 4. All right, let's go on to problem number 5. I think they're going to do one with subtraction. Yep. All right, so now it's about the pickup. But like I said, I'm not going to put a lot on you all tonight because this chapter is very tedious. And we're going back into factoring. All right, so now I have problem number 5. I have x minus 7 over 7 minus x. Now, for this problem, we cannot do what we did on the last problem. The reason why we were able to do it on the last problem because it was addition. However, this is totally different here. If I put in a number for x, I would get 2 different answers. So let's say if I plug in 1 for x, 1 minus 7 will give me negative 6. If I plug in 1 here, 7 minus 1 will give me positive 6. So those are 2 separate answers. So here's what we have to do. In order for these to be like terms, all right, you got to factor out a negative 1 in your denominator in order to reverse this. So now when we rewrite the problem, we keep the negative, that x minus 7. However, in my denominator, we factor out a negative 1. Now we can reverse this. X minus 7. And it should be negative 1 there. So now we have like terms in the numerator and the denominator, so now we can cancel out. In this section, when you have like terms in your numerator and denominator, you can automatically cancel those terms out. All right? So we factor out a negative 1 in order to reverse this so that we can get like terms. Now, you may be wondering, well, why we factor out a negative 1? Well, if we apply it back, negative 1 times x will give me negative x. Negative 1 times negative 7 will give me positive 7. Negative times a negative is a positive. So that's why we factor out a negative 1 in order to reverse the problem so that we can get like terms on the numerator and the denominator.
I have a question.
Yes.
Could you also just ignore the x and do negative 7 divided by 7? Because that's going to give you... No, that works for the problem prior to this.
Exactly. You see that? Because you're going to get 2 different answers. So now when we do this, we know that this cancels out. And anytime we have anything in the numerator, we got to replace it with a 1. So those terms will cancel out. And so 1 divided by negative 1 will give me negative 1 for my answer. So we do this just to get like terms. Like I said, in this section, all you're going to do is cancel out like terms. You're going to get like terms in your numerator, like terms in your denominator, and cancel them out. And that's why it's called rational expressions.
Can you do another one?
Mm-hmm. So I have x minus 5 over 5 minus x. So remember, we got to get like terms in the numerator and in the denominator in order to cancel them out. So the numerator is already set. But we got to factor out a negative 1. Just when you see this problem, just factor out a negative 1. Anytime you see a problem like this, where you have the same variable, same constants, but they're backwards, and the minus sign gives it away. The minus sign gives it away. you want to go ahead and factor out a -1 on the outside. Now that you factor out the -1, we can go ahead and write that. Now, because we have like terms now, we can cancel this out. So we can cancel here, cancel here. Now, if you have anything in the numerator, you can just replace that with a 1. And so now we have 1 divided by -1, which will give me -1. So -1 will be my answer.
Okay, that makes sense now. When you did the line first.
Yeah, sorry about that.
I thought it's okay. I just thought the x in the numerator and the 7 in the denominator were canceled.
No, both the whole equation. Okay, I got you.
Okay, that helps. Thank you.
You're welcome. All right, so now we're about to pick up. So problem number 6. Problem number 6. So now it's going back to what we learned in a couple of chapters prior. You're going to have to factor out the GCF in your numerator and in your denominator. All right, so now for this problem, we're just going to factor out the GCF. So the GCF between 5 and 10 is 5. Leaving me with x minus 2 in my numerator. The GCF in my denominator is 4, because 4 going to itself. So we factor out the 4, and that's going to leave me with x minus 1. And since we don't have like terms in the numerator and in the denominator, that is my simplified answer. So what I did was factor out the GCF in the numerator. 5 was my GCF. 5 going to itself 1 time, leaving me with x. 5 goes into 10 2 times. 4 is my GCF. Factor out the 4. 4 goes into itself 1 time, leaving me with x. 4 goes into 4 minus 1. So for problem number 6, we're just factoring out the greatest common factor.
Professor Newton,
Yes.
can I take give you my problem?
Sure.
I'll do it. I'll do it again. It's just first I want to see why it's not connecting. Minus 6x minus 30 over 5x minus 20. And what I did is the GCF on the top, isn't it 6? Because 6 goes in, right? And then to the bottom it would be 5, right? So it would be 5, and then minus 4. That's exactly what I have, and it told me it was incorrect.
No, that should be the answer. Let me plug in the answer and see what it says. All right. You know you can hit similar exercise, so go ahead and just submit the same answer and see what it says. The answer. What format do they want it in?
It says correct answer. It says B. Apparently it was not A. B, which is A.
Oh, right. Okay, my bad. Sorry about that. Okay, I didn't even read the question. It said to simplify the expression. So yes, that is absolutely correct. The expression cannot be simplified. Even though we factor it out, these supposed to be the same. Because I said, hold up, something's wrong with this problem. I know that this is supposed to cancel out. So yes, so the expression is not simplified. So yes, B is the correct answer. Yeah, because when we rationalize an expression, we got to simplify it. All right? And so something needs to be canceled out. Either the numbers on the outside should have been canceled out, or the numbers in parentheses should have been canceled out. Because I'm like, hold up, this should have been another number, but sorry about that. But at least you guys got an idea of where we're going. So yeah. So
you did say in the beginning we would end up with whole numbers mostly, right?
Yeah. So like I said, so you're either going to end up with a whole number or a binomial as your answer. All right. All right. So now I think the next problem is going to give us what we need. All right. So yeah. So I don't wasted all that time doing this problem. Yes. Thank you. All right.
You're welcome.
Problem number 7. All right. So we have 8x plus 48 divided by x squared plus 6x. So remember, all we're doing is factoring out the GCF. All right? Factoring out the GCF in the numerator, factoring out the GCF in the denominator, and keeping what's left inside the parentheses. So when I look at problem number 7, the greatest common factor between 8 and 48 is 8. So we bring out the 8. I'm left with x plus 8 goes into 48, 6. All right, so now I'm going to factor out the denominator. When I look at the denominator, the GCF would be x, the variable. So we factor out the x, leaving me with x plus 6. Now that we got like terms in the numerator and the denominator, we can go ahead and cancel those out. That cancels. That cancels. So now I'm left with 8 over x as my answer. Now, I showed you all the long way how to do this, right? I'm going to show you the quick and easy, simple way. When you see this problem, problem number 7, and it look exactly like this, but with different numbers, just take the first number and the numerator and take the variable x and put that in your denominator. And it will be your answer all the time. So when you see a problem exactly like this, especially if that's the GCF and you got a variable on the bottom of x squared, that will be your answer. Take the first number, which is the GCF, and then take the variable, and that's in your denominator. Works every time. Works like a charm.
Even if the signs is negative or positive, that doesn't
No.
matter.
They both got to be positive. They both got to be positive in order for it to work.
Signs are both negative, so just confirming. Both of mine were negative on the denominator, and
Oh yeah. As long as they both negative.
okay.
Yeah, if they're the same sign, yes. All right, so that's problem number 7. Problem number 7. All right, problem number 8. So what I'm going to do is I'm going to show you all the easy way to get the answers. I'm going to show you the long way because I want you to know how to do this. But then I'm going to go back to show you the easy way in getting the answers for this. And if I'm going too fast, please let me know. I'm trying to go as slow as possible because I know I'm not covering all of this tonight. I don't want to overwhelm you all with this lesson. Also, the practice final exam is open. So I encourage you all to go and start working on the practice final exam. If there's anything that you see on there that we've already covered that you still struggle with, shoot me an email. Let me know what problem number it is, and I'll make a video. I'll send you some resources to help you with that problem. But we don't want to wait up until the final to start working on the practice. We want to get ahead and start now. So I do this every year. I always encourage my students, go start looking at the final exam now. See what you know and see what you don't know. Because remember, we are one and done with the final exam. All right? You won't have 2 chances.
I have a question.
Yes.
I know you said that you're not teaching intermediate algebra next semester or whatever, but do you do any private tutoring?
Yes, I do, depending on my schedule.
Okay, because I know I got to take intermediate algebra before I could take actual college algebra next summer.
Right.
That's what's holding me from going to my program. I have to take this, another class, and then another one.
Right.
But I learned a lot from you. Like, I forget. Sometimes I forget, but I've never learned like I learned in this class.
Well, thank you. I appreciate that. I'll
get that information from you later because it's going to probably have to happen.
Right. Now, what I can encourage you to do is they are offering free online tutoring at the school, because you know that when you went to the school, they had the math lab, the science lab, where they had the academic tutors there. And that was a free resource for all the students that came to the college, to the math lab. They actually rolled it out. So now you actually have one-on-one academic tutors online.
Oh, okay. So now you'll have like a live person in school, or?
Yeah, you have a live person in school.
Oh, thank you, Jesus. Okay,
Yeah.
that's good then.
So you got the library learning commons. So let me be your last resort, because it costs a fee to use my service.
You know, you'll always be my first, because I feel like once you get into a groove of getting somebody's teaching personality, and I feel like comfortable with you when I don't understand nothing, I don't feel stupid asking.
Okay, no problem.
A lot of teachers can make you feel that way.
Okay, well, I'm not here. I'm here to make sure that you truly understand when you leave my class.
Thank you so much.
You're welcome. All right. All right, so we're up to, we're on problem number 8.
I know. When is the exam? December 9th?
December. Oh, let me check my class. Let me check my class. Because we missing Wednesday, so calendar. Bro, it's everything acting up. All right, so we have 8A tonight. We have 8 part 2 next week, and then we have 8B on the 2nd. 8B, yeah. So it will be the 9th. Yes, that is absolutely correct. So yeah, so the final exam will be Wednesday the 9th. So like I said, you want to start
online with you.
Yes. So I'm not going to do the so we will be doing it online together. So yeah, so like I said, you all will be able to do the exam with me like we've been doing the exam. So just be present that day. It's one and done. So like I said, I want you all to start practicing on the exam now, and getting familiar with what's going to be on the exam. And like I said, now is between now and the 9th is your opportunity to shoot me any email to any question or any problem that you see that you still do not understand, and I'll be sure to go over it with you before the exam. All right, so problem number 8. We have negative 4r minus 4s over r plus s. All right, so for this problem here, we're going to factor out the GCF in the numerator only. The denominator is already factored out. So we're going to factor out the GCF, which is negative 4. Now, when we factor out that negative 4, that's going to leave me with r plus s. And you're probably wondering, well, why is r plus s? Well, negative 4 times positive r will give me negative 4r. Negative 4 times positive s will give me negative 4s. So that's why that becomes a positive. So we factor out the negative 4. Since we have like terms in our numerator and in our denominator, since we have like terms in the numerator and the denominator, we can go ahead and cancel out those terms. So we can cancel out the r minus r plus s and the r plus s. And therefore, my answer would be -4. So now that I've done it the hard way, let me show you the easy way. When you see the problem that look exactly like this, where you have the negative and the coefficient are the same, and then you have that positive in the bottom, guess what? That first number right there is your answer. You ain't got to do all this work. That will be your answer. So just look at that first number. Look at problem number 8. Study it. You may see it on the test. So when you see this problem, you ain't got to go through all that work. That first number going to end up being your answer when you break that down. So just go ahead and take that number. And that's problem number 8. Problem number 8. All right, so now it's about to pick up because now we're going to actually start factoring. So I'm going to have to readjust my board. So now I gave you all the easy steps and all the easy concepts. With this next section here, there is really no easy way to do it. We're going to actually have to do the work with these problems because we're now going back into factoring. All right, so problem number 9. Problem number 9. Somebody had a question. For those that just came on, so I'm recording this in YouTube. So I will be able to send you a YouTube link so you can get the notes. So it is being recorded in YouTube. So on my YouTube channel, we're live right now. And I'll just resend the link to everybody as I send out the meeting for next Monday. All right, so problem number 9. We have z minus 4 over z squared. Matter of fact, let me just change it to x because my z's be looking like 2's. We have x minus 4 over x squared minus 16. Now, in the denominator, we have what is called a perfect square binomial, which goes back to chapter 7a or 7b. So that is a perfect square binomial. So now let's go ahead and simplify the numerator. Keep our numerator. However, we need to go ahead and factor the denominator. So now when we factor a denominator, remember a perfect square binomial, we're just finding the square root of that number. So when we find the square root, we have x plus 4 and x minus 4. So like I told you before, that whenever we have a perfect square binomial, find the square root of that number, it will be the same number but different operations. Same number but different operations. So now that we've factored that, we can go ahead and cancel out the like terms. As you can see, I have an x minus 4 in my numerator, x minus 4 in my denominator, and now I can cancel this out. Now, anytime you have canceled out anything in your numerator, if there's something left in your denominator, you have to replace a 1 in your numerator. And we only do this if you have something left in your denominator. And now when we finish the problem, it will be 1 over x plus 4. So remember, the key to doing this is understanding that for this problem here, you have a perfect square binomial. Just find the square root of that number. Okay? Remember, it's going to be the same number in parentheses. The only difference is the operations will be different. One will be a plus and one will be a minus. Once we do that, we cancel out like terms in the numerator and our denominator. And then we replace, because we have something in our denominator, we got to replace a 1 in the numerator. And that is problem number 9. And I think I'm probably going to go to just 15 tonight. Yeah, because it's about to start picking up. And this is where everybody start running into trouble. So I don't want to overwhelm you. If you remember factoring, you'll be able to get this. All right, problem number 10. We have a perfect square trinomial in our denominator. So because we have that perfect square trinomial, we got to factor that. So with this problem here, I have x plus 3 all over x squared minus 3x minus 18. All right, so now the numerator is already simplified, so we can just keep the numerator. However, we need to factor the denominator. Now, remember, I always told you that anytime we factor, right, you're going to automatically have 2 binomials for your answer. You automatically know that x and x will automatically go inside first. Now we find the factors of 18. 18 times 1, 9 times 2, and 6 times 3. Now we got to look at that factor and see which 2 factors, when I subtract, will give me 3. Well, the only two factors will be 6 and 3. So we can plug them in, 6 and 3. So we have our factors now. The last thing we need to do is get our signs. Well, since this is a minus and that is a minus, we know that the higher factor gets the minus sign. So therefore, the 6 will get the minus and the lower factor will get the plus sign. So the 3 will get the plus. Now we can go ahead and cancel out like terms in the numerator and the denominator. So we cancel those terms out. Remember, anytime you have something in your denominator, you got to replace it with the 1 in your numerator. Now that we've canceled those out, we can go ahead and write our answer as 1 over x minus 6. So the key to doing this is going back to that factoring chapter. So I told you we were going to come back to this. That's why when we were in that chapter, I wasn't really concerned too much because I knew you all were going to see this again. So I know that you were going to catch it the second time around. All right, and so that's problem number 10. And if you understood the factoring chapter, you will be able to do this chapter because all it is factoring and then canceling out the like terms. All right, moving on to number 11. All right, problem number 11. So we're still factoring here, okay? So I have x squared plus 4x plus 3 all over x plus 3. All right, I'm going to factor my numerator. So we know that we're going to automatically have 2 binomials for your answer. We know it's going to be x and x. Now we list the factors of 3, which is only 2 factors, 3 times 1. So we can go ahead and plug those in, 3 and 1. They must add up to give me 4, which they do. 3 plus 1 is 4. How do we know that it's plus? Plus, plus. So now that we've done the factoring part, we can now cancel out like terms in the numerator and the denominator. So since we have x plus 3 in our numerator, we can cancel them out. And we got x plus 3 in the denominator. So I'm left with x plus 1 as my solution to the set.
Professor Newton,
Yes.
Mine is a little funky because mine is where you have the 4, it's a 7, and where you have the 3, it's a 5. So there's no factors.
You said what? What?
So it's 2x to the second power.
Oh, you gotta use the Berry. You got. That's why you gotta use the Berry method. You're ahead. You gotta use the Berry method for that one. Remember that you gotta multiply the A times the C, and then get those factors that give you the middle term. So you gotta multiply A times C. So you're ahead right now. Yeah.
That's crazy. We're on the same problem on the 11.
Number 11. Are you sure?
Yes, yeah, mine is 11. It's 2x second power plus 7x plus 5 over x plus 1.
What in the world?
And I was originally starting the Berry method, but you weren't doing it, so I'm like, oh wait, I'm doing it wrong.
No, you do the Berry method. Yeah, well, do the Berry method on that. Yeah, you would do the Berry method on that one. That is so weird.
I still don't see. Okay, so if I do the Berry method, that means that 2 times 5 is 10, and the factors of 10, there's nothing that would equal 7. Am I?
Yes, it was. No, the factors of 10 is 5 and 2, and when you add them up, 5 plus 2 is 7.
It's been a long day. You're right. Okay. That's why you're the math teacher. You're right.
So, all right. So now we are. Man, I'm surprised they ain't giving y'all those problems, and my problems ain't. Okay, that's weird. That's really weird. All right. So problem number 12. Problem number 12.
Wait, before you move on, I'm sorry. So I did it. It's 2x plus 2, 2x plus 5, because those are the factors.
All right.
Then it's over x plus 1, so nothing cancels out.
Remember, you got to simplify that 2x plus 2. Remember, when you use the Berry method, you got to break it down by your GCF.
So a lot of added steps from the one you did, so that's why I was confused and not thinking about all of that.
Yeah, so with that one, you got to fully do the Berry method before you apply this. So remember, when we use the Berry method, right? If it has a GCF, you divide for your GCF to break it down. So you got the 2x plus 2. Break that down.
I got it now. Thank you.
You're welcome. All right, problem number 12. We are still in factoring. We're still in factoring. Now we're going to be factoring out the GCF in the numerator and then factoring the denominator. All right, so here we go. First thing we're going to do is factor out the GCF in the numerator for number 12. Your GCF will be the lowest x variable and exponent, which is x to the second. So let's go ahead and bring that x to the second on the outside. And then I'm going to be left with x plus 11 on the inside. So all we did was take the x to the second out. And because we brought it out, remember, that will go down 1. Now we can factor the denominator. We need to list the factors. Oh, sorry about that. Let's put our parentheses first. Skipping a step. We automatically know it's going to be x and x. Now, all we got to do is find the factors of 22. 22 times 1, 11 times 2. Now we got to see which one of those two factors, when I subtract, will give me 9. 11 times 2. So we go ahead and plug those in. 11, 2. Now we have a plus and a minus. So we follow the factoring rule. The higher factor will get the plus. The lower factor will get the minus. Because 11 minus 2 gives me 9. Now that we've factored out and we've factored, we want to get ahead and cancel out like terms in your numerator and in your denominator. So the like terms here would be x plus 11, so we can cancel that out. And our simplified answer will be x to the second over x minus 2. All right, so that's problem number 12. All right, so we're done with factoring for a minute. So now what we're going to be doing is we're going to multiply. We're going to multiply yes, we're going into multiplication now. So we're going to be multiplying rational expressions now. So we're up to problem number 13. These are relatively fun. Back to the rules we learned when we were in 6th, I think B, about exponents and polynomials. All right, so we have 15x over 5 times x to the 9th over 15, sorry about that, 3x to the 6th. All right, so whenever we have problems like this, we can go ahead and multiply numerator times numerator and denominator times denominator. So now just multiply straight across. We have x to the 1 times x to the 9th. That's going to give me 15x to the 10th. And then I'm just going to multiply 5 times 3x to the 6th, which would give me 15x to the 6th. So all I did was multiply straight across. Remember, anytime we multiply variables and exponents, we add the exponents. So that's how I got x to the 10th. Now, since I have like numbers in the numerator and the denominator, we can go ahead and cancel those numbers out. Now, if you remember the rule when we were dividing exponents, if we add them up when we multiply, what we got to do is take the smaller exponent, bring it to the larger, and then subtract. Well, the smaller exponent is in the the denominator. The larger exponent is in the numerator. So go ahead and bring that up and subtract it, and that cancels out. And so 10 minus 6 will give me x to the 4th power. All right, so that's problem number 13. Did everybody get the concept of this? Remember, we multiplied straight. One more?
Yes, please.
Okay. Still another problem. All right, so when we multiply, we can just multiply straight across. The numerator times the numerator, okay? So there's no number to multiply this 8 by, so we keep the 8, okay? Now remember, when we multiply exponents, remember any exponent by a variable by itself has an exponent of 1. So we're going to add the exponents. Keep the variable base, but add the exponents. So we keep the x. 1 plus 7 will give me 8. Now we're going to simplify the denominator by multiplying straight across. 2 times 4 is 8. And we just keep the variable and the exponent. Now, because we got like terms in the numerator and the denominator, if we look at our numbers, they're the same. 8 divided by 8 is 1, so we can just cancel those out. So we cancel the 8s out. Now we got to follow our rule for dividing exponents. Dividing exponents. It says to bring the smaller exponent to wherever the larger exponent is at. So the smaller exponent is in the denominator. The larger exponent is in the numerator. So we're going to bring that 3 up and we're going to subtract it. Remember, when we divide and they're both positive numbers, we are subtracting. We are subtracting the exponents. We added the exponents here. Now we're going to be subtracting them. So we'll go ahead and bring the 3 up. And we're subtracting it from the 8. And that will cancel in my denominator. Now we can go ahead and simplify 8 minus 3 is 5. So my simplified answer would be x to the 5th power. So when you multiply straight across, right, you're going to have the same number in the numerator and the denominator. So add the exponents that are on the top and then subtract them from the exponent on the bottom.
Cool, I got it.
All right, great, awesome. All right, problem number 14. All right, so we're back to factor. Oh, no, we're not factoring. Actually, yeah, we're going to factor. We're going to factor before we multiply. So problem number 14, we're not going to multiply straight across just yet. We got to factor out first. So factoring out the GCFs. So we're up to 14. We have x over 3x minus 15 times x squared minus 5x all over 7. So now let's go ahead and break this down first. So we can keep the x in the numerator, but we can factor out the GCF here. So I'm going to rewrite my problem as x over, the GCF is 3. So we bring out the 3, leaving me with x minus 5. So all I did was factor out the GCF in the denominator, which was 3. So for problem number 3, that first number will be your GCF. So factor that out and divide that number by that. And that's how I got the 5. Now I'm going to go ahead and factor out the GCF in my numerator. But when I factor that out, the x is the GCF because you have an x squared and an x. So let's go ahead and factor out that x. And that's going to leave me with x minus 5 all over 7. So now that we've factored everything out, we can cancel out like terms and then multiply straight across. We're going to cancel out the x minus 5 because those are like terms. So those are gone now. Now we can multiply. X times x will give me second power. 3 times 7 will give me 21. And so we just got our solution for problem number 14. So we do that first by factoring out the GCF. I factored out the GCF in my denominator, which was 3, leaving me with x minus 5. Because 3 times x is 3x. 3 times 5 is 15. We kept the minus sign. Then I factored out the GCF in the numerator. The GCF in the numerator was x. leaving me with x minus 5 over 7. Now that I have the like terms, we can cancel those like terms out here and here and multiply straight across by what's left. I got an x and an x. X times x will give me x squared.
Could you do another one?
Yes, I can. And when you hear me pause, I'm waiting. I'm waiting on y'all to say something to me, so that way I don't rush ahead. Oh, sorry. All right. So, base.
Did you mean to have a multiplication symbol in the middle?
Oh, yes, sure have. Lord have mercy. Thank you. All right. So, what we're going to do here is we're going to factor the denominator. We're going to factor out the GCF here. So we rewrite our problem. We have x in our numerator. 2 is my GCF, so that will be your GCF, so that will come out. And that's going to leave me with x minus 7. So I'm done factoring out my GCF in my denominator. Now I'm going to do the same thing in my numerator. However, your x is the GCF in your numerator. So we factor out the x, and that's going to leave me with x minus 7. So all I did was factor out the GCF. So in this problem, the GCF would be the x. In the denominator, the GCF would be the first number, whatever your number is. That would be your GCF. Now remember, anytime we have like terms in your numerator and your denominator, you can cancel those terms out. So since I got an x minus 7 here, that will cancel out. So I have an x minus 7 here, that will cancel out. Now, what's left is what I'm going to multiply. X times x. Remember, we're multiplying x. That's x to the first times x to the first. 1 plus 1 gives me 2. So that's going to give me x to the second power. Okay? And now we're going to multiply what's in my denominator, which is 2 times 3, which will give me 6. And that is my simplified answer to this problem.
Thank you so much.
You are quite welcome. All right. I think I can get a few more problems in. Before it gets back to the hard stuff. Yeah, we'll stop at 17. Because 18, Woo! Man. We'll stop at 17 tonight. All right, number 15. I don't even think I'm gonna have enough room on my board to do that problem. All right, so problem number 15. We have y plus x to the second power all over y minus x times y over y squared plus yx. All right, so all we got to do for this problem is factor. We really don't have to factor. The only thing we're factoring is this one. This y plus x to the second, we just write that twice. So let's go ahead and write that twice in my numerator. So we have y plus x and y plus x. So all I did was take the y plus x to the second and wrote it 2 times. And that's going to still be over y minus x. Now over here, all I'm going to do is factor out the x. Sorry about that. Factor out the y. Lord have mercy. Factor out the y because they both have y's. And it's going to leave me with y plus x. So in my numerator, all I did was write y plus x twice, because that's what that exponent tells us. In my denominator, I factored out just the y. Now, in this problem, remember, you can cancel out like terms in your numerator and in your denominator. It has to be 1 for 1. 1 for 1. So when I look at my numerator and my denominator, I have a y plus x. I also have a y plus x there. So I can cancel those out. I have a y here and a y here. Cancel those out. Guess what I'm left with? Y plus x over y minus x. So our starting point is to take the binomial in the numerator and write it twice. And then you're going to factor out the y in your denominator, or whatever your variable is, leaving you with y plus x, or whatever you have. Now for this problem here, these will cancel out and those will cancel out. Now, let me show you an easy way. Because this is problem number 15, if it looks exactly like this, this is your answer. That over that. Y plus X over Y minus X. So if you have problem number 15 right now, if you're up with me, just take the first numerator, denominator, and that's your answer. All right, I guess everybody got that one. So we're going to move on to problem number 16. Yeah, I'm just waiting on you all. Oh, you know, I haven't checked my time. If you complete it, we're going to go to 17. We're going to go to 17 tonight. We're going to stop at 17. Because 18 is where it's going to pick up at. And we're probably going to run into all the way close to 8 on next Monday. Even though it's only going to be 13 problems left, it's going to be a lot. It's going to be a lot. And I'm going to see if I can stay at my school to do the class for my school there. All right, problem number 16. Okay, we're still in factoring mode. Yeah, because we're going to start going back into factoring trinomials. There's going to be trinomial numerator and denominator. There's going to be trinomial. We have to use the Berry method. And then we're going to have to apply the keep, change, flip, because now we're going to go into dividing next. All right, so problem number 16. All right, so we have x squared plus 2x over 9 times 14 all over 2x plus 4. So all I'm basically going to do for this problem is factor out my GCF in my numerator and denominator. So when I look at this problem here, the GCF will be your variable for problem number 16. So when we factor out the GCF, that's going to leave me with x plus 2 all over 9. So all I did with my numerator is factor out the GCF, which was the x. The variable came out. And now I'm left with x plus 2. Now I'm going to factor out the GCF in my denominator. 2 is my GCF. So this will be your GCF for your problem. So the 2 will come out, leaving me with x plus 2. Now that I have like terms in my numerator and my denominator, I can go ahead and simplify and go ahead and cancel out like terms. So we're going to go ahead and cancel out like terms. We cancel out that. And we cancel out that. Now whatever's left, we can multiply straight across. Numerator times numerator. Denominator times denominator. X times 14 will give me 14x. 9 times 2 will give me 18. And then we can just simplify the fraction. So once I got to this step and cancel out the like terms, all I did was multiply straight across x times 14. That's how I got 14x. 9 times 2. That's how I got 18. And we can reduce that to a lower fraction, which should be 7 over 9x, 7x over 9. So when I simplify that, that will give me 7x over 9. Let me pull this back. So factor out the GCF in your numerator. X is your GCF. Factor out the GCF in your denominator. Whatever that first number is your GCF. Once you factor those out, the numerators will, and the denominator will cancel out. Then you can multiply straight across. X times 14 will give you 14x. And then 9 times 2 will give me 18. And then all I did was reduce my fraction, dividing both of those by 2. And that's how I got 7x over 9. All right. I think everybody got it. All right. Last question for the night. All right. So we're now going to be dividing. And here's where it's about to get a little complicated. Now, anytime, and this is just an example, this is not number 17. This is just an example. Anytime we divide fractions, right? The rule says to keep the first fraction. Change the operation to multiplication. And then flip the second fraction. And then multiply straight across. And simplify if you have to. So that is the rule for dividing fractions. We keep the first, we change the operation to multiplication, and we got to flip the second one. Because my board ain't big, I'm going to go ahead and when I factor out my GCFs, I'm going to go ahead and already flip my second fraction for these problems. All right? So when you see my problems, when I factor out the GCF, my second fraction going to already be flipped. All right? So I'm going to skip that step because my board is not big enough to do those extra steps. All right, so here we go. Number 17, last problem of the night. And like I said, I'm recording it in YouTube, so you all will be able to come back and look at it. I'll send you all the links. All right, so here we go. Oh, I just had it. So we have 13x minus 91 all over 27 divided by 9x minus 63 over 18. Now, I'm going to go ahead and factor out here. I'm going to factor out here, but when you see me factor, remember, I'm going to go ahead and already flip the second one. All right? So you're going to already see it flip. So we factor out the GCF. That will be 13, giving me x minus 7 over 27. Change the operation to multiplication. Don't forget, because we're going to be multiplying. I'm going to go ahead and flip the 18. So the 18 is going to come up. And now I'm going to factor out the GCF, which was 9, leaving me with x minus 7. Now I'm going to do two things here. I'm going to cancel out like terms, and then I'm going to simplify one of the fractions. So I'm going to go ahead and cancel out the like terms here. X minus 7 and x minus 7. However, 18 is divisible by 9. So I'm going to simplify that. So that will cancel out. 9 goes into 18 2 times. Now I can go ahead and multiply straight across. 13 times 2 will give me 26. And then there's nothing to multiply 27 by. And there we have our simplified answer for problem number 17. So the first thing I did was I factored out the GCF in the numerator. 13 was my GCF, leaving me with the x minus 7 all over 27. We changed the operation to multiplication. We flipped the second fraction. That's how the 18 got up here. And I factored out the GCF, which was 9, leaving me with x minus 7. We know that anytime we have like terms in the numerator and the denominator, we cancel out the like terms, which I did there. And then I went on and simplified this because 9 went into 18 2 times. And then I multiplied 2 times 13 because we are multiplying, not dividing. And then 27. And that's how we get our answer to problem number 17. And so we are done with these first few problems. Monday, you may see me at my school doing this lesson. So I'm going to check tomorrow to see if I'm able to use the Google meeting on my school. It gave me trouble before trying to use that link because we got a strong firewall there. But anyway, that is today's lesson. Did everybody get problem number 17? Would you like me to review it? Or we're good? We're good to go on problem number 17. Remember, I'm going to send you the link. I have a YouTube, so I will send you the link to the YouTube for you to watch this lesson over. All right. Well, since I don't have any response, listen, enjoy your Thanksgiving, everyone. Stay safe out there. And I will see you all next Monday. Listen, we are at the end of the course. Just 3 more lessons to go and 1 more test. And we are done. It is officially over. All right. So if nobody have any other questions, we are done for the night. I will see you all.